All right. Audio working for everybody? Great. So as introduced by Bodil, my name is Felix Geisendörfer. So those of you who don't know me, I run a startup called translated.com. We have cute little robots, so we don't have to do any work. What we do is we basically take file uploads that come from web browsers, then we process them, we encode videos, we resize images, and we put this stuff back in the cloud. And this app we run with Node.js. And I'm also a Node.js core contributor. In fact, I came to contribute to the Node.js core because in order to build Translated, we had to fix a lot of things that Node.js initially had bugs with or wasn't doing yet. We started using it very early on. I'm going to talk about that in a little bit. I'm also doing some open source projects myself. I do the Node MySQL client, which is a JavaScript client. So it's a re-implementation of the wire protocol in pure JavaScript. Not sure why you want to do that. You can actually bind to libmysql, but it's kind of my hobby project, and it's actually at a performance level where it's as fast as the C bindings now. And Formidable is a similar thing that does file uploads and that we actually use heavily for our service. And I've got a lot of NPM modules out there. And so, yeah, if you like the talk or not, my Twitter handle is Felix G. So what about the audience? How many of you guys consider yourselves backend developers? Okay, I'd say that's like 70%. How many of you have worked with Node.js? Well, most, I guess, half the people in the room. And anybody running it in production? Are you happy with it? If not, then talk to me. So that's what I'm going to talk about, running Node.js in production. When we first decided to use Node.js and put it in production, we had this imagination of how it would be. Because, I mean, Node was supposed to be awesome, and so we kind of pictured ourselves in a very heroic mission getting Node.js into production. And, well, it didn't turn out quite this way. Our first attempt looked more like this. That's what happens when you use really young, unstable software. When we started using Node.js, I think it was version 0.06, just a few months after Ryan released it. And it was basically unusable. But by the time we actually tried to launch, we were using version 0.128. So that was November 17, 2009 when this was released. And that version was pretty good and great, except for one thing. Just before we were ready to launch, we checked our log files on one of the development servers, and we came across a lot of Cs, and we're like, what are Cs? That looks weird, that's strange. Well, it turns out this was the error message printed before Node.js was completely crashing. So it would say success, and then the process would die. Unfortunately, we couldn't do like this thing that you do anyway, where you restart the service anytime it goes down, because we do file uploads. Some of these connections last for like 8 hours. So having people, what Seth actually was bitching about, disconnected at uploading 99% of their video is really, really bad. So we had to figure out a way to solve that. So that was the result of that thing blowing up. So what did we do? We did like a 6-week rewrite because conveniently the next version of Node that came out changed all the APIs. In the Node.js core, we had an API called promises. jQuery now does it, they call them deferreds. There's many names they go by, but basically it's an API where instead of passing in a callback, like we do now with Node.js, you'll return an object, and then on that object you can declare your callbacks. So there was like an add callback and an add airbag or something. Anyway, those are useful. Nobody could agree on a good API for them, so Ryan ripped them out, and that's why we have callbacks now, which are simpler, but have some other problems, like how do you cancel a callback? There's no interface for that. How do you cancel something you put in there? Anyway, so it delayed our launch, and so I could actually change this talk to how to not be like us if you want to run Node in production. But actually, things are a little bit better these days. Our rewrite went really well. We had the opportunity to actually clean up some technical debt. The delay was bad, but now we're getting to be a big service. We've processed 75 terabytes. We continuously run somewhere between 5 to 100 servers in production. We have really spiky load. So sometimes we have nothing to do. Our service just sits there idle, and sometimes people just send us terabytes of video, and then we need to spin up more machines quickly. And we're bootstrapped and profitable. So smart way to Node is what I'm going to talk about. How can you use Node and be successful with it? Well, the first thing is wait for Node to be stable enough. I think this one you can check off now. It's not a version 1.0 release, but at this point the API doesn't change much. The last big upgrade from 0.4 to 0.6 was fairly smooth, and the bug rates is pretty low. It works. It's good enough. And what I'm gonna also talk about is how to host on a PaaS, platform as a service solution. And instead of just like talking about all of this theoretically, I'll try something crazy which may go totally wrong. I'm just going to try to live code. I'm going to try to make a production service that's not hello world, that's not a blog post, that's usable and put in production, and we'll see how far we can get with that. So let's give that a shot. Okay, so I'm going to call that rebel resize, maybe giving away a little bit what it's going to do. The first thing we need to do, we need to come up with some name for our first file. I'm just going to call that server.js. And we're going to write the most simple things that could possibly work. So that would be a node creating an HTTP server, telling the server to accept this callback function, which is called whenever a connection comes in. You've probably all seen that by now. You get the request response, and you can just say respond.end hello world. And I promise that's not the end of it. And in order for this to work on me, I have to make it listen on a certain port. So that's port 8080. And let's see if that works. We're running the server now. And if I call up the server, hello world comes back on the command line. Is the font size okay for everybody? Okay, complain if not. Just to see if it also works in a web browser. Port 8080. Okay, not very useful, but at least didn't blow up on me. So how about doing something more useful? Let's say we have some image files that we want to work with, and the simplest thing we could possibly do with them is to display them. So taking them from our hard disk and getting them to the client. So in order to do that, we import the FS module, and we come up with a way to get this data from the disk to the browser. And so what we do is we say FS module, create a read stream for us. We need to give a path to it, so that can be our current directory name where this file is in, then /image, and then the request URL. This is not very safe. Don't do that this way. Somebody could get to your file system. So you end up with a stream object in Node. And I'm not sure how much I should explain about this. How many people have worked with stream objects in Node before? Okay. Then, yeah, it's not a lot of people. So I'll explain a little bit of what this thing does. It is basically a way to get the file or get data from any source and get events whenever like a chunk of data is read. So internally it does like read calls on the operating system. Whenever it has read a byte or a chunk of data, it gives you a data event. So you could kind of hook into it like this. You could say on data, and you'd get a buffer object, which is Node's way to hold binary data and also like an array-like interface. And then you could look at this buffer. You could use it like an array, do things with it. And so in order to find out when you have all the data, you would define an end event, and that fires when everything has been read from disk. So these are kind of useful. What's even more useful is that they compose pretty well. So we can say that the stream thing here is a readable stream, and our response object here is actually a writable stream. So we can take the readable part and pump it into the writable part. So what we can do here is, stream.pipe response. And if we're lucky, we should have a static file server. What we also need is some files. I have some laying around here. No, they're hiding. Here we go. So there's a few files in there. So those are the one we're going to try out. Okay, let's try to get the dino image. That works. Fair enough. Let's try another one. It's like a picture of a lake. Oops. Oh, and there we have the first problem. Browsers do this neat thing where they trick you when they really make one request. They also make another one to get the fav icon. And sometimes that with Node is annoying. Frameworks would take that away from you. So in our case, we just say request. Or actually, we could do error handling. So errors on the readable stream. So we do stream on error. Then we just say console.error. And that would take care of it for us. Now if we do that same request again, the lake comes up and we have the error message in our console. That's a little better. Okay, that's not really useful. What's, however, already pretty cool with this is that you've done a streaming file server. So instead of taking the whole file from disk, loading it into memory at once, and then sending it to the client, you've taken like little pieces of data from disk, and as those data is read from disk, you send it on to the client. So there's very little memory overhead. It's an efficient, smart way to do it, especially if you eventually would get big files. However, there's already software out there that does it really well, like Nginx. So why in the world would you do that? Well, it would get interesting if we were to do something dynamic with it. So for example, we could try to actually not just show those files, but resize them. How would we do that? Well, in most platforms, you'd probably look for some add-on, some binding to GD library or ImageMagick or something, and then use that. That's very doable, but that means you have another piece of software that kind of needs to compile. And I've had bad experiences with many languages with that, where people on different computers had problems getting it to work, and it's just frustrating. What, however, works fairly reliable and it's also easy is to execute something on the command line. As long as the command is where you think it is, that's very doable. And there's a lot of really cool command line tools out there. The only problem is that every major language that I've worked with, every major platform, has really terrible bindings for executing other programs. Does anybody know a language they like other than Node for executing other programs? Yeah? You what? I like Clojure for everything. You like Clojure for everything. And that's a simple way to think about it. But I actually think that with Clojure, you're going to be stuck with a Java interface, or do they have a own wrapper for? I don't know. Clojure I've not honestly looked at, but with Python, PHP, and all these things, what you usually get is a function that allows you to execute another program, and then it will do stupid stuff like, by default, print all the output to your console. I don't want to do that. I want to get it in a variable. So you ask it for getting it in a variable. Now you're like, oh, it's not that simple. You have actually multiple streams coming out of those things. There's standard out, there's standard error. So shit, you look for other functions, and then you'll find one that gives you kind of the standard error and the standard out mixed together or separate. But then you, like, what about these other things, the exit code, signals, and there's like so much stuff going on. And by the time you get to the point where you try to stream that data out rather than having the platform buffer it for you, it's really, really frustrating. With Node, and that's one of the reasons why we picked it initially, this interface is really, really nice. And this allows us to do cool things. So for example, we can now use a command line tool from ImageMagick, the convert tool, and actually use that to do our image resizing. So let's try to do that. I need the spawn function, which comes out of the module called child process. It's a part of the Node core. And what I need to do is I need to create a convert process. So I would say convert equals spawn. Convert is in my path, so it will find it. I'd recommend that whenever you have softwares that you shell out to, make sure your environment is always configured to have it in the path. Don't start like configuring where the location of the binary is. It gets really annoying and difficult to do on multiple computers. Now we need some arguments. For the arguments, we can say that our first argument is where the data is coming from. The data is coming from the disk, so this is the path argument. The second one is we want to do resize, and we want to do a resize to 100 times 100 pixels. And then what do we do with the resulting file? Well, luckily in Unix there's a convention where if you use dash as the name of the output file, it usually means print to standard out. So we don't have to actually take our resized file and write it to disk. We can directly get it on standard out. So what we can do with this now is we can take the convert tool that we just launched, process running in the background, takes the standard out, and pipes it into our response. And since we're good people, we also do the error handling. So we can take the convert standard error and pipes that to, well, process that standard error. That's another writable stream. If something goes wrong, we'll have at least an idea what happened. So let's see if that works. So this picture is pretty big, so it should take a little while to resize. Okay, fair enough. As you notice, image magic is nice enough with us that it keeps aspect ratio. If we wouldn't want that, we can actually go in and say, I want it to be really 100 by 100 pixels with an exclamation mark, and then it should do that as well. Okay. Now, I promised it would go a little further than Hello World, so let's try to take this at least as far that we could imagine it doing something useful in production. So let's first of all make this dynamic right here, the dimension that we resize to. So the way we could do that is we could split our request URL in then parts. So request URL split on slash, and then our path would be the first element. Why is it the first and not 0? That's because the URL starts with a slash. Parts. Oh, that's good. Thank you. Now you don't see me getting the error. Anyway, parts 1, and then for that part of the argument, we can say parts 2. And if we have no other errors, we should have a dynamic image resizing server now. So we can say, I want this in 400 pixel, and that works. We can also take another image. Here's one of Feynman, and Feynman is awesome, so he should be bigger. Come on, be bigger. Oops. So that's kind of cool. But I feel like with Node.js, we have to like add at least another buzzword. So let's bring some cloud into this, and see if we can actually take the image storage location that's currently on the disk and make that Amazon S3, like in bucket. I've already prepared an Amazon bucket right here. And this is the part where I hope the internet will work nicely for me. Well, let's assume the internet is working nicely. Okay, here we go. So there's the same images already in there. So just so you know what I've set up so far. So let's try to actually take the images from Amazon S3, then resize them, then display them to the server. So how could we do that? Well, the best way to do that would be to first get some credentials for our Amazon account. I have those stashed away right here. So if we open this config.js file, we'll see some credentials. Also another thing if we get to it. And so we basically have a key, a secret, and a bucket. And this Amazon account is limited to exactly that one bucket. So you shouldn't be able to screw with it. Well, you could delete the files now if you want to be really mean. So, but hoping that nobody does that, let's try to actually get our data from there. So what we'll need is some clients that can talk to S3, because we don't want to make those files public. They're our originals. So they say we need to authenticate with Amazon. And in order to do that, we're going to use a library called Nox. And Node has a really nice package manager. I really like NPM, so it's quite nice to get this module. And with our friend Nox here, we can get into the server again and create an S3 client. Let's say S3 is equals require nox.create client. And the S3 config, we need to get that config from somewhere. And so the first thing we want to do is load the file. So the way we do that with the S3 client is we're going to say request.get, s3.get request URL. It's a bucket layout. It's the same as the path that we use. Well, actually, never mind. We've already done the splitting part here. So that's the one we would use. The URL for on the Amazon S3 account is a slash plus a file name. So we send off that request. Then we define a response handler. We have to call end here for some reason. I don't like that API. We do get an S3 response back, and that response should now contain the file. And again, in Node, we have these streams, so that S3 response is also a readable stream. And what we're going to do is we're going to get this code back in here. And then we're going to tell our ImageMagick arguments to, instead of taking the path from disk, to also take the path from the command line, in this case, our standard in. Same convention here. If it says an input argument, use dash, it means standard in. And now what we have to do is we need to take the S3 response and pipe them to our other response object. And, oops, that's totally wrong, sorry. Pipe them to convert.standardin. And if we're lucky, that should work. Let's see. Okay, that's cool. So this is kind of nice, but there's one problem with it. It's kind of inefficient. Every time somebody wants to view an image in a certain dimension, we're like going out to another web service, Amazon S3. We get the file from there. Then we pipe it into ImageMagick. ImageMagick probably doesn't start to do the image resize until it has actually buffered up all the data. I assume it does buffering. And then it does the resize on the image, and then that comes back out. And it just takes very long. Like the conversion itself can take long. So for example, if we try to do that with the lake image, which is like several megabytes, we'd probably wait for a very long time depending on how the internet connection is treating us. So let's actually put in a little cache. So once we have resized an image once, let's keep the result in memory so we can reserve it really quickly. And so in order to do that, I actually wrote a little npm module called stream cache. And what this basically does, it takes all the data from a stream, readable stream, and buffers it up just in memory. And we need to include that stream cache. And what we need to do is whenever we send something out, we also want to populate the cache while it's going out. So we're going to create a new cache, new stream cache. And then we're going to say convert.standardout, also pipe into this cache, please. Then we need a way to store all our caches somewhere. So let's do that really hacky by having this little variable. And what we can do is caches dot, we need a cache key. The request URL is actually a very good cache key in this case because it contains both the file name and the dimension we're resizing to. So we can use request.ul, and we're going to set it to our cache. And then all we have to do is whenever we get a file in or a request coming in, we check our cache first to see if the request URL response is already cached. And if that's the case, we're going to take that cache and pipe it directly into this response and return early here. And if we're lucky, that should work. Let's see, I have this image, which let's actually see how big those images are. Find one that can download. The Dino one is probably good, 700K. So it should take a little while on the first request, and then we should be able to see the speed up on the second one. Helps if I start the Node server. Okay. Okay, that worked and took a little while. And now if we do it, it's rather fast. snappy. We could also verify that real quick on the command line. Takes that URL and def null it. So yeah, 14 milliseconds. That's pretty good for serving image from cache. But if we now again would resize it to something else, it would again have to get it from say 3 bucket, do the resize in the new dimensions, then would be cached. So we could still optimize this further by also adding more caching for the original files and stuff like that. But I think this is good enough. This is actually something we could put in production and see some use in it. So let's try to put it in production. And what I'm going to do for putting it in production is I'm going to deploy to Heroku. They do Node.js hosting. Many other companies do. I don't particularly endorse them, but they work well in my testing. So first of all, we need to create a package.json for our application. So just to tell it what's in there. We can do npm init, which kind of helps us create this JSON file. Our test app. And just ask us lots of stupid questions. We're going to just say yes to all of them. What we now have to do, which is important, is we need to tell the node version. This is a Heroku-specific thing, where it will actually look at this for your applications and decide what node version to use. The next thing we need to do is we need to create a Git repository for this. So let's do a Git init. And actually, let's move the image folder out of the way because we don't want to check that into our Git repository. Now we can, well, actually, we probably want to exclude the node modules folder. So we do git ignore for that. Node modules. So that looks good. That's probably the files we want to check in. With Heroku, you probably wouldn't check in the config.js file. They have other ways to do config handling, but we're going to do that for the demo. One thing that we need to adjust in our server, though, is they don't allow you to listen on any port. So actually set it up where you get the port to listen to from the environment. Oops, that one works better. And so we're just going to default to 8080 if we're locally, but on Heroku, we're going to use what they recommend. Now we can check those files in. First commit. There's one other thing we need to do. We need to create a proc file that basically tells Heroku how to start our server. So that was a little fast. Sorry. What's in there is basically web, which says this process is on port 80, and then it tells it. We tell it how to start our process. So Heroku, now we have to create an app. So I think it's apps create stack cedar, and then we can give it a name, rebel resize. Okay, and we created the app, and if we get really lucky, then we should now just be able to do git push Heroku, and it should just magically work. Okay, that did not work. Oh, I had this while I was practicing, so I know what I did wrong. I forgot to actually specify my dependencies, my node modules, when I created my package.json file, so the Heroku can start up my application right now. We can do that the simplest way by basically reinstalling them, and when you use the -s option with npm, it will automatically add the file to your package file, package.json. So we had the stream cache, and we had Nox. I actually don't know if it takes both. No, it does. And if we get lucky, yeah, it added it to our dependencies. So now we should be good to go. And let's push that to Heroku again. Cool, that worked. Let's see. No. This is not good. We have to read the log files. No web process running. Anybody see it? Pretty sure. Say that again. It's a proc file? I thought I did. Oh, thank you. You guys are good. It even says so on my little command line thing. Proc file. So it says it's installing our dependencies, discovering the process, declares the type web. Maybe it's their smart application cache thing. No. It's not looking well for me, I have to say. No process running. Yeah, the stream cache is in here, yeah. Let's see if I'm using anything else that I wasn't aware of. I use stream cache and I use Nox. I have some both added in. Heroku was saying I was getting them. Heroku is broken. Let me go off and just see if it helps if I create a... Well, actually, no. I don't think it would help. This is very annoying. I practice this a lot. No, it should be fine, but it's a good point. Let's see if I have a typo in the port I'm listening on or something. Process environment port. Actually, let's add a little log ourselves. I have a little time to screw with this. Listening on port, and when we type in the port, do that here, and say port equals process environment port or 8080. If we do that, it works locally. Let's commit that and see if it shows up in our Heroku logs. No, I guess I failed. That's what you get. I'll continue with the rest of the slides, and meanwhile have my subconscious figure out if I can fix it before the end. So the point I was trying to make is deploying on a path is a really good idea, unless you're doing a live demonstration, then it will fall apart on you. But it actually frees you from worrying about a lot of things you have to worry about when you try to host something yourself. But there's reasons to sometimes do that, depending on if costs are a problem or if you're building something they cannot handle well. For example, with the case of Heroku, they would not be able to host something that does file uploads well, because their philosophy is that web applications are these shared nothing processes that actually can be terminated and restarted at any given time. So they don't guarantee you that as they scale up and down and move you in their like virtualized environment, that they sometimes won't just cut off requests that are in flight. And so you couldn't use them for stuff like that. So if you have to actually host it yourself, there's a few things I can talk about that will make your life easier. The first thing you need to decide is, do you want to go for the cloud or do you want to have a more traditional hosting company? What I can say is, for a small thing you're starting out with, it doesn't really matter. Use whatever is easy to get access to. You want to have SSH access, that's it. For the longer term, it depends if you have these really spiky traffic patterns like we do with going from 5 to 100 servers. So higher costs if like Amazon actually pay off for us. But if you have something that grows in a predictable way and you can actually do capacity planning, there's less of a reason to use cloud services for stuff like that. With Amazon, it's a little bit different because they also do all these value-added services around it, like Amazon S3, which is really good, and a bunch of other things. And it helps if you're local to those. But otherwise, use whatever works. So the first thing you're going to run into when you host yourself is you probably want to listen to port 80, because as we know, port 80 is one port to rule them all. It's the most important port in the world. However, evil is always looking out for it, right? People are trying to get to you through that port. And so you need to be smart about how you run your applications there. So the biggest problem with it is, in order for on a Linux system or Unix system to run something on port 80, you need to have administrator root privileges. And you probably don't want your web process to run as root if you can avoid it. So what you do is, there's 3 ways to actually solve this. The first one is to start your program as root, and then listen on the port that you're interested in this case 80. And once you have that port open, that file descriptor in your hands, then you drop your root privileges by basically changing to another user. And then the process will continue to run, but now as a user with less privileges. That's a simple and good way to do it. Another kind of neat way that I also like is to use IP tables on Linux. So what you can basically do is take traffic that comes in on port 80 and redirect it to another port. Now, in order to set up this IP tables rule, you have to be root. And I think you also need to take care of that it's still there when it reboots. But once you've set it up and got this going, it's kind of simple, flexible. You don't have to worry about this whole port thing. You don't have to run your application differently in developments and in production. It's convenient. And the third way, which also has its benefit, is to actually use a reverse proxy. Use another web server in front of Node.js, for example, HA proxy or Nginx, because there are pieces of software that have seen more battle than Node so far. They're kind of more stable. But what's more important, they also have a lot of features that Node.js does not have out of the box. So before you start building your own static file server in Node.js, which is idiotic, use Nginx. Let Nginx handle static files, and anything that's not a static file request, you can delegate to Node. You do, however, need to watch out with both Nginx and HA proxy, because Nginx especially loves to buffer when it's talking to its backend services. I think that's because, correct me if I'm wrong, but up until recently, at least, Nginx was still HTTP 1.0 solvers, so it only supported HTTP 1.0, and so I think it has no chunked encoding for sending stuff back and forth, but there was something with that. And so file uploads or WebSockets will not work with Nginx. HA proxy, as far as I know, the latest version, I'm not sure if they tagged it stable yet, handles both. But you'll have to experiment. This WebSocket thing is causing problems with a lot of these proxies. The next thing is you kind of want your process to stay alive. Even if you do good error handling and Node is not crashing on you, it shouldn't. But you'll sometimes get a runtime exception because it's JavaScript. You're going to access a property that's just on a non-object and things like that. And what you want to do is you want your process to come back to life after that. And the way you do that is you use a service like Upstart, which is now built into Ubuntu, or Monit, which you can install anywhere. And these are pieces of software that basically monitor other software, make sure it runs, can test actually if it's still running, if it's healthy, and if the process is gone or it seems unhealthy, then it can kill it and restart it, and make sure it just stays alive as long as the server is online. What you want to do is you want to make sure to log those crashes, because you probably eventually want to fix them and figure out why your process is going down. Especially if you're building something with long-running connections, then it's going to be important for you. Deployment itself. What I like to do for deploying is I like to have a build server running, and that build server basically installs my NPM modules, but it also actually makes sure Node is compiled in a local folder within my project folder. So I vendor Node into it, and then I make a package that actually contains my application as well as Node.js itself. And that package, that tar.gc, can actually be deployed on any other machine as long as it has roughly the same kernel and architecture. So architecture is important to kernel. Make sure it's similar. And that's really nice because you can do these atomic deploys where when you deploy, you're not only deploying your application, you're also deploying your stack. So upgrading Node.js, for example, is no different than making a change in your application code. And that means you get the same rollback automatically. It's really nice. I like it quite a lot. And for the actual deployment, I also like to use my build server. So I would add another build job, which basically would trigger a little script. That script would get a list of all my machines to deploy to, then upload the tar.gc, stops the old application, and then starts a new one through SSH. Node is actually kind of nice for that because you can shell out to SSH and have even multiple SSH sessions going in parallel easily. Fork. Cluster.fork is something you need if you want to run Node on more than one CPU. I have to say for this, if you're writing a Node application and you find yourself CPU bound, you probably screwed up somewhere. So if that's like your main concern in life, maybe revisit the choice of Node. But if you just want to make sure you use all your kernels, use cluster.fork. It's built in module, and it will help you spawn multiple processes. They will all listen on the same port and share the same file descriptor, and the load balancing to these different Node instances will actually be done by the kernel. It's efficient. Metrics. Add as many metrics to any system you build as you can. It's probably the best and only solid piece of advice that applies to anything you put in production that I can give. With Node.js, there's a library called Node Measured, which I wrote, which I like. And there's services where you can then send your time series data to. They'll store them for you, and they'll display them. Graphite is an open source project to do it. Librato is a hosted web service. Just pick what you like, and just measure early, measure often. And measure everything: requests per second, events per second, response times, number of items in queue. Configuration, I highly recommend to have most of your stuff come from environment variables. It's okay to have like a JavaScript config file as well, but it should always look in environment variables first. That makes it super easy to deploy in different environments, to make changes on the fly, and to just separate your configuration from your actual application. The Heroku guys are heavily pushing that, and I think it's a really good model. And if you locally need to store some config values, you can just write simple bash files that you can then source from the command line before you start the application. If you're interested in this kind of stuff, I highly recommend 12-factor. Has anybody read that? Okay, those who have know it, but for everybody else, this is basically a site Heroku put together where they describe everything, how they feel applications should be built and hosted in order to scale horizontally. And I think it contains really lots of solid advice. So that's most of the content right here. One last thing for all of you guys who like Node.js, don't be this guy. It's a guy who's like, I need to build an uber scalable web service. Will be the next big thing. And then he has this brilliant idea. Easy, I'll use Node.js and MongoDB. No, that's not how you build scalable things. It may be fast, like in some silly Hello World benchmarks, but building something scalable is actually really, really difficult. So stop looking at Node as like a magic unicorn. See it more like this. This is how I like to watch Node. It's like duct tape for the web. It's a pragmatic solution to some concurrency problems that if you do not have them, don't use Node. But if you do have them, it's like stuff you wrap around it. It works and will get you going much faster than fiddling with Erlang or something else. And if you want to build something where people make phone calls that decide over life and death and it needs to be up with like 5 nines at the end, then look for other solutions that are more industrial strength. But for the web stuff, webby stuff we build, it doesn't matter so much as long as we can maintain the complexity of the code. So Node.js is good for IO-bound workloads, streaming data, long-running connections, because the event nature kind of, I feel, makes it natural to program. And if you do this thing where you have lots of code on the client side, so sharing between server and client-side code is doable with Node.js. And today, you shouldn't miss this one. The Dragon spaceship will today dock with the ISS station, so make sure to watch out for that. That's going to be cool. All right, questions? Thank you.
Actually, I'm not sure I have time for questions.
Send no questions, but find me.
No, I mean, it's going to eat into lunch. So if anyone wants to ask a question despite that, we can have